Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
I
love that word.
Hello and welcome to Diffusion. Sit back and relax while we engineer weird and wonderful science beamed directly into your ears. I'm Ian Wolfe. On this edition, Frank Marchese from the SETI Institute talks about the search for extraterrestrial life and intelligence. First up, here's news of a different kind of invisibility. Invisible in water. Real-life cloaks of invisibility work by guiding light waves around objects without touching them, instead of bouncing off and into the eyes of observers. Researchers have found ways to bend water waves around objects to make it seem that the water had never touched them. This makes a ship's passage through the water invisible. Bending the water waves this way would also reduce the drag of the water on the ships, allowing them to go faster with less fuel. The watery cloaks of invisibility may even stop ships from rocking, because they just don't feel the waves. The same techniques might also find applications with sound waves and even the elastic waves from earthquakes. Two teams have found two different ways to solve the problem. They're similar to the two approaches used in hiding objects from light waves: waveguides and metamaterials. Researchers from Zhejiang University in Hangzhou, China, set up an experiment to shield a toy boat from big surface waves in a water tank. Along each side of the wave tank's long narrow channel, the researchers laid steel beams that gradually sloped upward to a flat region and then back down. This changed the depth of the water at the edges of the tank in a way that adjusted the speed and direction of incoming water waves. The toy boat in the tank's centre sat almost motionless as the waves rolled in. A series of such beams could be constructed in a port to stop boats from bobbing wildly while being loaded with cargo. In their paper, the researchers explain in detail how the waveguides could be used in wharves and ports. Their paper was titled Broadband Waveguide Cloak for Water Waves and was published in Physical Review Letters. The other team at the Massachusetts Institute of Technology have designed a new metamaterial that can shield an object in a stream of moving water. The material is made of hundreds of tiny pillars, each 50 micrometers in width, that encircle the object to be hidden. The interaction of the water with the tiny pillars makes the water behave as if it's thicker, more viscous, which alters the way the water flows. As a result, water downstream flows as if no obstacle had been in its path. A ship coated in this metamaterial would be invisible to the currents. The reduction in drag caused by the metamaterial could lead to ships that need less fuel. Their paper was titled Hydrodynamic Metamaterial Cloak for Drag-Free Flow and was also published in Physical Review Letters. You're listening to Ian Wolfe on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Extraterrestrials? Frank Marchese is a senior planetary astronomer at the SETI Institute. He's also Chief Scientific Officer at Unistellar, a company based in France and San Francisco that makes robotic smart telescopes. I spoke to him by Skype from a very windy street corner. We talked about the search for life on other worlds, the search for intelligence in the universe, and laser SETI. I began by asking him, what does the SETI Institute do?
So the SETI Institute is a non-profit organization located in Mountain View, nearby San Francisco in California. It's an institution which has 73 researchers at the moment. And those researchers are basically looking for life in our galaxy, our universe. So there is various ways to find life in our universe. Most people know the SETI Institute for the research we started 35 years ago, roughly, with Jill Tarter and Frank Drake, where basically they use antennas like the Parkes array or the Allen telescope array that we have at the moment to search for technosignatures. So basically the signature of a civilization, some radiation coming from a civilization which, like us, is emitted radiation because of their TV, their radio, their radar, or simply because they want to say they are here. The second way is to search for life in our solar system. So there is a lot of planetary astronomers at the SETI Institute which are looking for life in our solar system because we know there is water in our solar system. We know, for instance, there is more water underneath the crust of ice of Europa than there is on Earth. We know there is weird activity at the south pole of Enceladus, a moon of Saturn. So SETI Institute researchers are involved in designing or using instruments made by NASA space mission to search for life in our solar system. And finally, the third way, which is the way I kind of lead a few years ago, and I'm not the chair anymore, but I still work in this field, is of course to search for exoplanets, planets in orbit around other stars. We know now there is 2 planets in average around each star in our galaxy. So it means that there is a lot of worlds over there. And in fact, 30% of those worlds could be Earth or super-Earth, so terrestrial planet. And we know as well that a large portion of those planets, 10% at least, could be in what we call the habitable zone on a star, where we can find liquid water on the surface if they have the right atmosphere. So exoplanetary astronomers like myself are looking for life by trying to image and to characterize the atmosphere and the surface of those terrestrial and super-Earth exoplanets.
Right, and there's been little bits of news, I think, this year about some exoplanets that they've found that might be in the habitable zone.
Yes, so in fact, Kepler is a mission designed by NASA and also operated at NASA Ames. The SETI Institute has been involved in this mission intensively. It is because the SETI Institute researchers designed the pipeline to detect transit of exoplanet from the Kepler data. So after 4 years of operation, the Kepler spacecraft has been able to show that there is planets almost everywhere in our galaxy, and have been able to detect some very interesting exoplanets. Planet close to the star, not too far away, not too close, with the right temperature, that if they had the atmosphere like Earth, they could have liquid water. But there is something very important here, and that's something I mentioned yesterday during my talk at Macquarie, is that we did not yet see a planet like Earth. What Kepler has been revealing is the existence of a planet that could have life if it was like Earth. But Kepler did not see the planet. Kepler saw the shadow of the planet. And by seeing the shadow of a planet, you don't have much information about the planet. You know the size and you know the orbit. If you really truly want to see if there is life and detect what we call biomarkers in the atmosphere of this planet, you basically need to image this exoplanet. You basically need to compute instruments capable of getting such a good image quality, so you will be able to see the faint, a billion times fainter planets orbiting its star. And that's the true challenge of astronomy at the moment.
Are we able to tell a little bit about the atmosphere from the light that goes through it when we see the shadow?
So when we see a transit, in some cases, if we have the right instrument, we can derive information about the atmosphere by spreading the light during and after the transit. This is what we call spectroscopy by transit. This is very difficult to do because the signal of the transit itself is very small, so the signal of the atmosphere is even smaller. So we need to have specific instrument built for that. JWST, the next space generation telescope, will be able to do the study of transiting exoplanets for a few of them and characterize the atmosphere. And maybe if you are lucky, even detect the atmosphere of an potentially habitable exoplanet. The Europeans are planning a mission called Ariel, which is a space telescope that has been designed specifically to see the atmosphere, to detect the atmosphere during transit and be able to characterize this atmosphere. So it's impossible, but it's difficult.
And is it going to become possible to image the planets?
So we are working on various instruments to image planets. And in fact, we have already imaged exoplanets, a few of them. Been working for 10 years, roughly, on JPI, the Gemini Planet Imager. It's an instrument designed specifically to image and characterize Jupiter-sized, Jupiter-like exoplanets. So we're talking about very massive planets in orbit around their star. In 2015, we announced the discovery of 51 Eridani b. It's basically a planet twice the mass of Jupiter with the same atmosphere, orbiting 10 times the distance of the Earth's sun, so 10 AU from its star. That's the first true Jupiter-like exoplanet ever discovered and ever seen using adaptive optics technology. So we have seen various additional ones recently, but now the difficult step we want to do is to image and characterize Earth-like exoplanet. And the problem is way more difficult because exoplanets like Earth are small, very small. So they are 10 billion times fainter, invisible than their star. So we need to have even better instruments. So we need to have larger telescope like the ELT, the Extremely Large Telescope we are building right now in Chile. It's a project led by ESO, and Australia is part of this collaboration. So with this kind of large telescope, we think we will be able to image and characterize Earth-like exoplanet. SETI is also involved in one additional mission that I kind of like because it's a very low-key but extremely successful, potentially successful mission called Project Blue. Project Blue is a space telescope the size of a fridge with an aperture of 30-40 centimeter diameter. It's a telescope dedicated to image one specific planetary system, the Alpha Centauri A and B. Those are two stars located only 4.2 light years away from us, so very close to us in the cosmological background, we say. The size of the galaxy is 100,000 light years, so that's very close. That's a closer stars to our sun. And this Project Blue Space Telescope is equipped with the same instrument than JPI, an adaptive optics system. And simulation have shown that if you observe those stars for thousands of hours, typically 4,000 hours for A and B, we will be able to image and characterize in visible light an Earth-like exoplanet. So give to the next generation of explorer, of astronomer, the first picture of an Earth-like exoplanet. And that will be exciting.
It'd be very exciting. What are some of the characteristics you'll be looking for to see that there might be signs of life?
So to see sign of life, what we need to be able to do is to spread the light of the planet and see what we call biomarkers or imbalanced chemistry. So biomarkers are typically those molecules that you expect to see if you have life, a biosphere on the planet. So that will be, for instance, the presence of oxygen, the presence of methane. Typically, those are the very easy biomarkers. People often say, well, you are looking for life like ours, so you're looking for biomarkers like we have on Earth. But in fact, people at Harvard University, like Sarah Seeger, or at University of Washington, like Vicky Meadow, are working on modeling a different type of life and trying to basically provide for the next instrument some biomarkers of biosphere that will be different to the biosphere of Earth, finding what we call imbalance into the chemistry of the atmosphere of a planet.
So you're looking for chemistry that won't happen just by lifeless chemical reactions.
That's correct. And it's very difficult to be able to separate those because nature is way more imaginative than we can imagine. So in fact, nature always find a way to trick us. Thanks to volcanoes, we can have methane, for instance. And maybe there is some unknown geological phenomena that will produce this imbalanced chemistry. So there is something I know is that the day we're going to find those biomarkers, or we're going to have indication of the existence of lives on a planet like Earth, there will be a huge debate in our community. People claiming that those are not biomarkers, but geological traces of activities. And that will be a long conversation, but that's normal because it's going to be such a huge discovery to find life elsewhere that we will need to basically have lengthy discussion to convince ourselves that what we see is true.
And isn't that what happened with even the Viking mission to Mars all those years ago, that its chemical sensors came up positive, but they weren't certain enough for people to be sure that there was any sign of life chemistry rather than just unliving chemistry?
That's correct. One of the experiments of Viking was basically indicating the possibility of existence of life. It has been kind of dismissed because the other one was not suggesting the possibility of life. So people kind of dropped the ball on this and decided that there was no life on Mars. Right now, I don't know if you have seen recently we have seen an outburst of methane on Mars. And we have no idea where this methane is coming from. It come up and out, and come up and come back on a regular basis. And space mission in orbit around Mars have seen it, and the rover on Mars, the Curiosity rover, has detected it as well. So there is something happening on Mars, and we don't really know if this is life or this is a geological activity on the planet that it's unknown. And I think this is a very interesting mystery at the moment in our field.
It is. So as well as trying to tell life from non-life, how can you tell signals from intelligence over naturally occurring radio signals?
So a signal of an intelligent civilization will have a structure. So basically, it will be very different to noise. It will have a structure in a way that it will basically, if they want to tell us they are here, for instance, they will probably send us some kind of mathematical simple information like prime numbers or repetitive signals. If those signals are coming from TVs or radio emission, TV-like or radio-like emission, because I'm not assuming that those aliens will be listening and watching TV, of course, we will quickly recognize those signals from the background noise. They will be organized, there will be pattern in it that will indicate they are not natural, but they are artificial.
Do you think we would be looking for beacons rather than just their background information exchange?
So the SETI Institute already been thinking about that. We are working on a mission on the telescope called Laser SETI. And Laser SETI is trying to find not radio emission, but laser emission. This is like the ultimate beacon of light, of course. So in this case, will be a laser produced by a civilization which is trying to tell us that they are here. Maybe we do have these signals coming on and off in the sky, and because we don't really look for them, we don't see them. So the Laser SETI instrument, which is going to have its first light in the next weeks, is basically an instrument that monitors the sky 24/7, 12 hours 7, because you need to be dark to be able to do that. and will basically be able to detect automatically the projection of a laser coming from an extraterrestrial civilization.
It must be very difficult to screen out all the signals from all the satellite and all the other things that are going on around the Earth.
Yeah, it's very difficult, and we have stories of people believing that they have discovered a signal of an extraterrestrial civilization, and ultimately found out that it was a satellite, a military satellite. It does happen, and we have a protocol. In fact, if one of the antenna, like the Allen Telescope Array, for instance, detects something, we will communicate quickly with the next station capable of observing this signal in Australia or in Arizona or in Europe, China, etc. And they will be basically following this signal to see if it's changing, if it's decreasing, and if it contains any mathematical information or any pattern, for instance. That's the best way for us to make sure that we are not observing some kind of activity, unknown military activity, for instance, coming from a rogue satellite.
And the square kilometre array that's being built, will that be doing any SETI activities?
Are you talking about the SKA?
The SKA, yes.
Yeah, the SKA will have a SETI component. I'm not part of this project, so I just can tell you what I heard and when I talk about with my colleagues. The SKA will basically have a team searching into the signal for patterns, for structures indicative of the existence of extraterrestrial technological signal. So there will be this. Of course, the SKA is not designed for that. The SKA is designed to conduct observation in astronomy in general, but it's taking a lot of data, and we will basically process this data to be able to detect any indication of technological signal coming from it. So one of the aspects of our research at the SETI Institute is that we also want to engage people in our research. It started with SETI at Home, that a lot of people have been using over the past 20 years. You probably remember the screensaver that SETI set up, which was allowing people using the idle time of the computer to process data for SETI. That was SETI Berkeley took over this project, and it's still in existence. SETI Institute is now doing a new type of project. We partner with a company called Unistellar, which is a company which is designing a robotic smart telescope. And this robotic smart telescope will allow anybody, any of you, to become a citizen astronomer. You will not know anything about astronomy. You will be able to observe, enjoy the dark sky, observe galaxies, nebulae, using this telescope. It's a very powerful telescope. We have the same sensitivity like a 1 meter class telescope, and participate to citizen science. So SETI will be able to send notification if something is happening in the sky, like a new comet, for instance, or a supernova, or even you want to participate to the search for exoplanet. You will be able to use your telescope to detect transit of Jupiter-sized exoplanet recently discovered by TESS. So that's another way of making people involved in astronomy. Thanks to this telescope, it's kind of, you will become a citizen astronomer, and maybe one day, Laser SETI will detect one of these laser pulses that I mentioned previously. And in this case, we will need you, citizen astronomer, to follow this signal, to be able to tell us if it's still happening wherever you are on this planet. So the Laser SETI and the Unistellar could be basically the next instrument network that will discover the existence of technological civilization.
And where do people find the SETI Institute online?
The SETI Institute can be found at seti.org, SETI.org. And the Unistellar page is at unistellaroptics.com.
Well, Frank Marchis, thank you very much.
Thank you very much, Ian.
That was Frank Marchis, Senior Planetary Astronomer at the SETI Institute, talking about the search for extraterrestrial intelligence. Find out more about the SETI Institute at seti.org and about the Unistellar telescope at unistellaroptics.com. And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @IanWolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. Please listen next week for an interview about a kinder, gentler transhumanism. I produce Diffusion, which is broadcast around Australia to 28 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, 3MBR in the Mallee Border districts of Victoria and South Australia, City Park Radio 7LTN in Launceston, Tasmania, 2XXFM in Canberra, and my local station, 2RDJ in Burwood, New South Wales. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to the podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com. And check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 950 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/IanWolf. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Wolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.